All right, I'm going to work through the final exam review for Chapter 3 in Algebra 2. So I've got a bunch of, these are all quadratic equations, so they would be parabolas if we graph them. And it says solve using any method. I'm usually going to go for factoring if it's possible. If we can't factor, then we might have to use a different technique. Okay, so there's not much room to show my work here, so I'm going to use the scratch paper here. So let's see, number 1, x squared plus 16x plus 60 equals 0. So this looks factorable to me. I'm going to factor this with a diamond problem. I'll put a 16 up here and a 60. I'm looking for two numbers that add to 16, the same two numbers multiply to 60. 10 and 6 will work, right? 10 plus 6 is 16, 10 times 6 is 60. That tells me what goes in the back of these parentheses. Okay, and then I can use the zero product property. One of these two things has to equal 0. So that means x would equal negative 10, or x is going to equal negative 6. Okay, so there's my solutions there. Here, I'll put my answers in on this. Okay, all right, on to number 2. Now, on number 2, if I wanted to factor this, I'd first have to set it equal to 0 and subtract 49 from both sides. So I could do that, but I'm also noticing that the left side of this equation on number 2 is already, this is kind of set up for completing the square, because I've got a perfect square trinomial. Okay, so if I factor the left side of this equation here, if I set up a diamond problem like this, I'd have 4 on top and bottom. So it's going to be 2 and 2. So I've got x plus 2 times x plus 2 if I just factor that side. Now I did say, you should set it equal to 0. That's if we're going to solve this using the zero product property. But since this is a perfect square trinomial like this, well, now I can just take the square root of both sides. Okay? And when you do that, don't forget, when you take the square root of a whole equation, 7's the square root of 49, but so is negative 7, right? So there's a positive and a negative root there, okay? And then I've almost got x isolated. I'll just subtract 2 from both sides. I'm going to slip that in front of the plus minus, okay? And then let's actually simplify this. We can do this. Those are like terms, so don't leave it like that. So if I had negative 2 plus 7, that would be positive 5. If I had negative 2 minus 7, that would be negative 9. And there's my solutions. So yeah, if you set this equal to 0 and factor it and solve like I did this one, you should end up with that same solution. I was just noticing that I had a perfect square trinomial on the left side. Okay, so next up, it's getting a little bit more difficult here because I've got a coefficient in front of the x squared term. And my leading coefficient is negative, which makes things a little bit harder. Okay, I'm going to try to factor this. So I'm noticing that, hey, everything's an even number, so I could just divide this whole equation by 2. 0 divided by 2 is going to be 0, and that's fine to do that. But I'm actually going to divide everything by negative 2, because that way I'll have a positive leading coefficient, and I think it's just easier to factor when you have a positive leading coefficient. So that would leave me with, negative 3x plus 1 equals 0. So now I got it down to that, okay? All right, so now let's try to factor this equation. So I can't factor out the 2, so I'm going to have to do something else with this. I'm going to do a modified diamond problem where I'm going to take the 2 and multiply it by the 1. I'm going to change this trinomial. So 1 times 2 is 2. Okay. Then I'm going to attempt to factor this with a diamond problem. Okay, so I'm looking for two numbers that add to negative 3 and they multiply to 2. So 1 and 2 are if I do 1 times 2, that's positive. But if I do negative 1 and negative 2, that works out. Okay, so I've got x minus 1 times x minus 2. Okay. Now, I modified the problem. I changed the trinomial, so I got to change my solution here, okay? So in the beginning here, I multiplied by 2. So now I'm going to divide the constants by 2, just the number parts by 2, okay? And if you can't reduce the fraction, just pull the 2 out in front of the x there. And then the 1 falls to the ground. And then 2 over 2 is 1. So there we go. Now this is factored, and now I can use the zero product property. So one of these two things, again, is going to equal 0. Okay, so there's my solutions for that one. 1/2 or 1. Okay, put that in up here. Okay, maybe I'll try to zoom out a little bit so I can get that all on screen. Okay, number 4. 4 up here. We've got 3x squared plus 22x minus 35. The first thing I'm going to do with this one is set it equal to 0. So I'm going to move I'm going to add 35 to both sides. Okay. Now looking at this one, it's possible that it's factorable. So you could do a modified diamond problem thing. I'm just knowing if I do that 3 times 35, that's going to be a pretty large number, and it'll be kind of a pain to do in that way. So another way, if you don't want to do a modified diamond problem, you can kind of just think about FOIL. I'm not even sure if this one's factorable or not, but honestly, this is how I would try to factor it. I just think, okay, 3x squared has to be 3x times x, and then the last parts in these are going to give me the 35. So I could do 1 and 35. I could do 5 and 7. Or I could do the double negative versions of those, but the double negatives would give me a negative number right there. So I'm going to try either 1 and 35 or 5 and 7. I'm feeling better about 5 and 7, so I'm just kind of penciling this in. I don't have a pencil actually, but really lightly I'm just trying this out. And then I'm thinking, can the outer and inner give me 22x? This would be 21x and 5x. No. So let me try switching the order of them. 7 and 5. Okay, that would be 15 and 7. Okay, I like that. So those last gives me 35, but then the outer and inner, 15x and 7x, would give me 22x. So hey, this is factored. Okay. Another option, if you don't want to factor a problem with large numbers, just use the quadratic formula or complete the square, but quadratic formula would be easier on this problem because of that coefficient there. Okay, so now I can use zero product property. Okay, and I've got -7/3 and -5. Okay. All right. Let's move on. Maybe I'm going to flip this paper around so I can use the top of it on these last two. All right. So these two, since they're not trinomials, what I'm going to do on numbers 5 and 6 is just isolate the x squared first and then take the square root of both sides. You could put like a 0x in the middle and treat it like a trinomial, but I think it's just going to be easier since there's only one term with an x in it, just to isolate the x. So subtract 4, divide by 49. Okay. And then take the square root of both sides. Don't forget positive and negative square root of that fraction. Okay. Now, what we can do with that negative is it's going to be the square root of -1 is going to be I, right? So we can think of this like that, and then this part's going to just be I, right? The square root of -1. So I've got plus or minus I times the square root of 4/49. And square root of 4/49, I can do something more with that as well, actually, because I can split it into √4 over √49, and those are both perfect squares, so that's going to give me 2/7. Okay, so this is plus or minus I times 2/7, but we'd usually write that like so, 2/7 I, right? You wouldn't say x 2/7, you'd say 2/7 x. So it's just a variable, right? Okay, so there's 5. Let's try number 6. Oh, let me put my answer in here. All right, Number 6, I'm going to add 54 to both sides first. You could actually factor this one too. That would work too. So let's see. 6x squared equals 54. I'll divide by 6. X squared is going to equal 9. Take the square root of both sides, so it's not just going to be 3. It's going to be plus or minus 3. Okay. All right, so there's that batch. Now on these next problems, we've got some graphs. Use the graph to determine the number and type of solutions of the quadratic equation. So all of these are second degree equations, which means they're going to have 2 total solutions. Okay, the real solutions are going to be x-intercepts. But sometimes if there's not enough x-intercepts, that means there can be some imaginary solutions. So this first one, I can see it's got 2 x-intercepts, so that means 2 real solutions. Okay, now this one's a little confusing because it looks, yeah, there's only 1 x-intercept, okay? But that one is going to be a double root, so it's going to be a double solution. So it has 1 real solution, but it's a double one. So anytime instead of crossing over the x-axis like this did, these are both single roots, this one does a little U-turn right here. So it touches there and then turns around. When you have that U-turn situation for an x-intercept, which is going to happen at the vertex, right? When the vertex is on the x-axis, that's going to be a double root. Okay, so you could say here that x is going to equal 3 twice. So you could just list 3 twice. It just doesn't ask me what the solution is, but that's what it is. Okay, so I've got 1 real solution here. But it's only 1 because it's a double. It's a solution twice. Okay. All right, this one never crosses the x-axis at all, so that means 0 real solutions. But if it has 0 real solutions, it still has to have 2 total solutions. These are all second degree. So that means the other the 2 solutions are going to be imaginary. Okay, so we always have to get to a total of 2. And that's why I wanted to show you that that one's a double one, because we actually do have 2 solutions in a sense, because it's the same one repeated. Okay, this one we've got 2 solutions there and there, so 2 real solutions. The x-intercepts are real solutions. Any other solutions are going to be imaginary. Okay. All right, got a word problem here. The Freedom Tower in New York City is 1,776 feet tall. Okay, here's an equation that models the height. So the height is f of t in feet, and then t is going to be time in seconds. Okay? After how many seconds will the object hit the ground? So it's going to hit the ground when the height is 0. So this part is the height, right? Okay, so let's see if I can fit this in over here. So for part A, I'm just going to put in 0 for the height. And then I'm going to solve this for t. Okay? So I'll subtract 1776 from both sides. I'm trying to get the t squared by itself. And then I'm going to divide by negative 16. Okay. That's going to come out to 111. Okay, now I'm going to take the square root of both sides of this equation. Means plus minus. But wait a second, we're talking about time here, so you can't go back in time, really, right? So for my final answer, I'm just going to use the positive root, because that's the only one that makes sense here. Algebraically, it's positive or negative, but in the context of the word problem, it's not. And I'm just going to round to the, oh, it says round to the nearest hundredth, so that's going to be 10.54 then. Okay, so my time then, it's going to hit the ground after about 10.54 seconds. So let's put in let's put in the units since we know what they are, and it's a word problem, right? I always want the units on a word problem. Okay. Okay, and then part B says, what is the height of the object 3 seconds after it has been dropped? So here it's telling me the time. So I'm just going to plug 3 in to this this equation for t. So I'm finding f of 3. I'm finding the height after 3 seconds. Negative 16 times 3 squared plus 1776. So then it's just PEMDAS, right? So I'm just going to do the exponent first. Okay, so I've got negative 144 plus 1776, and that's going to give me 1632, and then my height was in feet, right? So let's put that in. Okay, so building 1776 tall after 3 seconds, that's where it would be. Okay. All right, let me put these answers in here. About 10.5. Oh, this was for part A. I wrote them in the wrong place. That's for part B. Whoops. Okay, so next up we've got some complex numbers. All right, flip over my scratch paper here. Okay, a complex number, this is a complex number. It has a real part followed by an imaginary part like that. So I'm just going to combine these. If I wrote this without parentheses, I'd want to distribute the negative into the second binomial, right? So 2 minus 5i plus 4i, plus 4 minus 2i, and then I just combine the like terms. So this is the same as if the I was an x. It's just a variable. So I've got 2, and then let's combine these into negative 7i, and yeah, this is equivalent to negative 7i plus 2, but usually complex numbers, you write the real part first, then the imaginary part, okay? Okay, and then this one, we're multiplying these two complex numbers together. So before I get too far into this, let's talk about what I means again. I is the square root of negative 1. So I squared, if I squared this radical over here, then that would equal negative 1. So anytime I have an I squared, I want to simplify it to negative 1. Okay? So with that in mind, let's take a look at this expression here. Okay, so I'm going to FOIL this. So first, 3 times 1. Outer is going to be negative 18i. Inner is negative 3i. Last, okay, this is going to be 18i squared. It's a negative times a negative, right? So 18i squared, okay? I've got these like terms that I can combine. So a lot of times I'll see this as the final answer, but as I was trying to describe up here, we can simplify this further. I squared equals negative 1. So here I have 18 times negative 1. That's just negative 18, right? Okay, and then I can simplify this further because I got more like terms. So that's going to give me negative 15 minus 21i. Okay, and I'll put the real part first in my final answer. Okay. Okay, let's take a look at the next page. Okay, we've got a system of equations now, okay? So this is going to work pretty much the same way that it would if we had two linear equations, two lines intersecting. So we can do elimination, or we can do we can solve this by substitution, or you could do it by graphing, but that's more work than we probably want to get into. But here I've got two parabolas, so it could have two solutions, right? It could have two intersections. I'm going to do substitution. Both of these are equal to y, so that makes things nice. So I can take this quantity and plug it into the second equation where the y is. So that would give me negative 2x squared minus 6 equals this. Okay, and now I've got an equation that only has one variable, so I should be able to solve this for x. Okay, so I'm going to start rewriting this. So a lot of times I'll see people distribute that negative into the binomial. Don't do that because you have to square first, right? This is multiplication. I want to do the exponent first. So I'm first going to FOIL this. I want to think of it like so. Don't just square both terms either. Okay, so let's see. First would be x squared. Outer and inner are both going to be negative 3x, so that would give me negative 6x. Negative 3 times negative 3 is 9 for the last. Okay, and now I'll distribute the negative here. Okay, got it down to that. And now I want to combine the like terms. So I'm going to add 2x squared to both sides. And I'm going to add 6 to both sides as well. I'm going to do these both in one step just to save some time here. So I'm going to have this and add 6 to it. Okay, so let's see. On the left, then I just have 0. On the right, that would be x squared plus 6x. Let's see, I'd have negative 1 plus 6 would give me 5. And this is looking a lot better now, right? This is I can factor this. So that's what I'm going to do. So 1 times 5 is 5. 1 plus 5 is 6. And then 0 product property. So hey, I am going to get two solutions here. I'm going to get two places where my parabolas would intersect. Okay. All right, let's try this next one. So we could get one solution if they have the same vertex or something, or we could have 0 solutions if the parabolas just don't intersect. Maybe one opens up and one opens down and they don't overlap. Okay, but anyways, let's try out number 15 then. So I'm going to do the same kind of thing. This one's going to be a little bit more difficult because I've got to mess with the equations a little bit. So I'm first going to just isolate the y in the top equation. So I'm gonna stick in the negative 8x in there just so it's kind of in standard form. Now I've got y is equivalent to this, so that means I can plug all of this into the second equation where the y is. Okay, so my second equation would be x squared minus this quantity. So I'm using parentheses there when I substitute that in. That's important, because that will remind me that I need to distribute this negative, okay? So now I've got this equation with just x's, so I should be able to solve for x. Okay, and I'm going to go ahead and move the 10 over to the left side as well. So it's equal to 0, and now let's start combining like terms, okay? So let's see, I've got those two will give me 3x squared, and I've got the x terms here. I'll box those. That's going to give me 2x, and then 8 and 10 would be 18. Okay, so I can't factor out the 3 here. I could try to factor this. I could do a modified diamond problem and see if it works. If it's not factorable, I could still solve it with quadratic formula or completing the square. But let's go ahead and try this. So squared plus 2x, that's going to be 54. Okay, so then I'm thinking, can I get two numbers that add to 2 and multiply to 54? So 1 and 54 is no good. What about 6 and 9? No. Okay, I don't think there's a winning combo there, unless I'm just... yeah, 2 and 27 is no good. 1 and 54 is no good. 6 and 9 is no good. I'm thinking, yeah, I don't think there's a winner there. 3 and 18 is no good. Okay, so what I'm going to do then is I'll go back here. That was a dead end with the factoring. It happens sometimes, right? That just wasn't factorable. So I'm going to go back here, and I'm going to use the quadratic formula. So here's the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. You could complete the square, but it would be kind of a pain with that 3 there. You'd have to, well, let's not get into that because I'm doing it this way. Okay, so let's see. My b is going to be 2. My a is 3. And my c is 18. This is all over 2 times a. A is 3. Okay, so I got that. I'm running out of space here on my scratch paper, so I'm going to start working this way. Okay, I've got 4. Let's see, 4 times 3 times 18 is 216. So I'm going to be subtracting 216. I see, that's why I couldn't factor it, because I'm going to get an imaginary solution here. Okay, all right. Okay, -2 plus or minus square root of negative 212 over 6. And I can rewrite that as I root 212, right? Because the square root of negative 1. Okay, and I'm going to start breaking down the 212. Oh, sorry, I'm off screen. I'm going to start breaking down the 212 and seeing if I got any twins in there. See if I can simplify that. Okay, so 212 is 2 times 2 times 53. I was just dividing it by 2. Okay, sorry, this is getting cramped here. Whoops, off screen again. Okay, so got a pair of twins, right? So one of those is going to get out. So got negative 2 plus or minus 2i root 53 all over 6. Almost there, but I can still do a little better than this because I can see all 3 terms there. This term, this term, and this term. They're all even numbers, so I can divide everything by 2. Which means this will be negative 1 plus or minus I root 53 all over 6. No, 3. I forgot to divide by 2 on the bottom. Negative 1 plus or minus I root 53 all over 3. Okay, that's a long one. Okay, let me get that answer in on my actual sheet. Oh, I forgot to put this one in too. And over here I had negative 1 plus or minus I root 53 all over 3. Okay. All right, moving on. We've got an inequality. All right, so I'm going to graph the related parabola here, but one thing you want to look out for is if this is underlined or not. Here, this little symbol is underlined, so y is greater or equal to, which means I'm going to have a solid line. But when I draw the parabola, but if it wasn't, if it was just y is greater than without the equal part, then it would be dashed. So always be on the lookout for that. Okay. So hey, I know this parabola is going to open downwards because I've got a negative x squared term. Okay. I also know, so, you know, I'm kind of just thinking about minus 4. So if I wanted the y-intercept, I could plug in 0 for x. So my y-intercept is going to be negative 4. Okay? If I want the x-intercept, I can plug in 0 for y. And I can solve this for x, okay? So I'm just going to divide the whole equation by negative 1 here so that I got some positive. X squared plus 4, negative 4. Okay, and then, hey, wait a second. This is going to be imaginary, right? This is going to be plus or minus I root 4 or plus or minus 2I. So I'm not going to have x-intercepts, and that's because this is going to open down from here, okay? This is actually going to be the vertex, and it's going to open down from there. There's no stretch or compression either, so it's just going to open down in the shape of the parent graph. So, you know, I go down 1 to the right and left 1, and then I'm going to go down 4, 1, 2, 3, 4, right and left 2. So here is, and you could always plug in some more x, y pairs, or more x's to get the y's that go with them, okay? So here is my parabola. It's drawn with a solid line, and the next part of this is to shade it. I'm going to shade above the parabola or below it, one side or the other, to show all the points that work, okay? Two ways to do this. You can choose a test point, like just plug in 0, 0 and see if it comes out true or false. If it's true, then I would shade the true part. And the false part's not going to be shaded. You can also, if this says greater than, which it does, if you have the y on the left side, that means you're going to shade above. Okay? If it said less than, I'd shade below. So I'm going to shade above the vertex. So I'm going to shade in here. Okay? Any point in there, like 0, 0, would work. I'd have 0 is greater or equal to negative 4. That's true, right? So there we go. Okay? Next problem is the same kind of deal, except we've got two parabolas to graph on the same axes. And heads up on this graph that's provided here, if you look at the scale, we're counting by 2's here. So that's really annoying when that happens because it's easy to miss that, but pointing it out now. Okay, so here let's graph this first one. Maybe I'll do these in some different colors just to have a contrast going. So here I'll do this one in blue. So I'm going to set it equal to y first. Okay, so I subtracted x squared from both sides, and then I'm thinking, okay, this is going to be open downwards because it's a negative. And then it's going to be just like the parent graph, except it's going to be shifted up 2 units. So you could use the axis of symmetry formula and then find the vertex, but the vertex is going to be 0, 2, and it's going to open downwards from there. Okay? So remember, I'm going just the parent shape here. I went down 1 to the right 1. I'm going down 1 to the right 1, but that's where the scale of this of these axes can mess you up. Okay, and then I'm going to go down 4, so 1, 2, 3, 4, right and left 2, like this. Okay, now this one should be solid because it's underlined. Okay, and I'm going to be shading below this one because it says less than, so I'm going below the vertex. So just lightly, I'm going to do that. Okay, so now let's look at this one. Okay. So I want to isolate the y again. So I'm going to move everything over to the other side. I'm going to add the x squared. I'm going to add 2x to both sides. I'm going to subtract 6 from both sides. So that's what that would look like with that. Okay, so this is going to be my y-intercept. Okay, if you think about plugging in zeros for x's, those will just drop out. So my y-intercept is going to be negative 6. Okay. Let's find the x-intercepts. I can find the x-intercepts by factoring this. Is it factorable? I'm just thinking about this. 1, 6, or 2. No, it's actually not factorable, so I'm not going to do that. So let's find the axis of symmetry. X equals negative b over 2a. My b is 2. My a is 1. So x equals negative 1 is the axis of symmetry. So that means that is the middle of this parabola. Okay? Let me zoom in here. I just want to have a vertical line going 1 to the left. And my vertex is somewhere on this. Okay? So my vertex is going to be the point negative 1 something. I just got to figure out what that something is. And the way I'm going to get that is I'll go to the equation and plug in that x and see what I get out for y. I don't know why I stopped using my scratch paper. Kind of need the space here. So I've got 1 minus 2 would be -1, -7. Okay, so this would be -6, -7. Okay, so it's right about there. Okay, and then I could get the x-intercept, but they're gonna I'd have to use a quadratic formula or complete the square to do that. So I'm just gonna stick with this. Now this one, since I've got this heads up on this, it's dashed. Okay, and then it says greater than when I've got the y isolated, so I'm going to shade above. Okay, so when I draw the parabola, make sure it's dashed, and then we're going to shade above that. Okay, and the actual solution to this, to the system of inequalities is the double shaded part, which is that overlap part right in there in this one. Okay, so I'm just kind of emphasizing that it's this stuff. Okay, all right, one more problem. We've got a toy rocket fired straight into the air. Okay, the rocket has an initial velocity of 48 feet per second, and here we've got an equation to model it. So t is going to be time, h is going to be height, time in seconds, height is in feet. At what time will it reach its maximum height? Okay, so I know we're firing this straight up into the air, but let's just pretend, just to draw it, it'll be a little easier if you think of firing it off at a little bit of an angle, so that we can see that this is kind of a parabola here, and we're interested in the maximum height. Okay, so this says at what time will the toy reach its maximum height, right? So my x-coordinate is going to be the t, and the height is the y-coordinate. So my answer is going to be the t. So it's the x-coordinate of the vertex. That means I can just use the axis of symmetry formula, because that will give me the x-coordinate of that, right? Because that'll give me this line, and then that'll give me the x-coordinate there, right? The t-coordinate actually. Okay. So axis of symmetry is like this. Yeah, for this one, it's actually the time is -b over 2a. My b is going, oh, and this is interesting too, heads up here. This is not in standard form yet. So I'm going to rewrite it like this. Okay, because it's really easy to say that your a is 48 and your b is -16, but that's not the case. A is -16 and b is 48. Okay. It's -16. So that's going to give me -48 over -32. Hey, a negative over a negative is positive. That's good because you can't have a negative time. Wouldn't really make sense. And then that's going to give me 1.5. That'll reduce to 3/2 or 1.5. So 1.5 seconds is when it will reach its maximum height. Okay, and that is it. That's it for the review. See you next time.